Howdy. We are watching windy. We are watching SO2 emissions. And there is still this SO2 plume, or however you want to call it, which originates somewhere from Algeria. So that's how many hours? 18 hours ago. It was like that. And it's a pity I didn't catch it as it started. So I don't know exactly what's the original starting point of this emission. It seems to be somewhere here. It might be also here. I don't know. But just for comparison, there is like Etna is active, there's a new vent and stuff, there's volcanic activity, but it's compared to this plume much smaller. For example, let's go over to somewhere else where we have volcanoes. Mexico. This might be Popocatépetl. I don't know. Might be, because Popocatépetl is at the moment very active. If you are bored, check out some live stream from Popocatépetl. And where is Hawaii? Is this Hawaii? Honolulu. It seems to be Hawaii. There is almost nothing emerging from Mauna Loa or Kilauea. There are a few spots here in, what's the place called of that? Polynesia, maybe? No, I don't know. And here, of course, we have some CO2 emissions in China, India, and others. But that's something very interesting. I don't know what's going on there, but it seems to be that there is something going on. Otherwise, we wouldn't have this rather prominent SO2 plume emerging out of northern Africa. Now we are going to forecasts. They don't help us too much in order to figure out what's going on there. And for those who don't know, there is this interesting event also, which now it's 3 days, I think, where we had this unconfirmed quake in Algeria. And here it's visible on the bigger map. So follow the red line and you will find the quake here. Approximate location of the quake. There is a mountainous region just beside it. Water bodies are there. And I found a paper which made some surveys in this blue area. The study area, which is here. And our quake is somewhere here. And of course, that's not accurate. It's approximately where the study area is. And you know, I've been talking about the white rivers and all these kind of things, Mountainwater. And that's the Arabian Journal of Geosciences, combining geology, hydrogeology, and groundwater flow for the assessment of groundwater in the Sahretz Basin, Algeria. Abstract. The Sahretz, or however you pronounce that basin, is one of the endorheic, I don't know what that means, basins of the vast steppes region, which is located in central northern Algeria, about 300 kilometers from Algiers, covering a surface of approximately 9,000 square kilometers. Geological, hydrogeological, and hydrochemical and groundwater flow data are integrated and used to evaluate and characterize groundwater resources to identify the main factors controlling groundwater flow in the region. The hydrogeological characteristics of the aquifer system show that Turonian sediments from the principal aquifer in the northwestern part of the study area. This aquifer is continuous with an aquifer of Miocene-Pliocene Quaternary age on the northern flank of the Dielfa syncline. The mean hydraulic conductivity of the Turonian aquifer is about 10, 4 meters per second? It's not cubic meters. I don't know. But anyway, let's go to page 13 or something. Here is the map. Actually, sorry for scrolling back, but that's the map. You just saw the study area. And that's how it looks. This is where I got this other map from in my picture. We need page 13 or 14, I guess. 12, 13. Chemical water types. Nitrate combination. Contamination. Where is it? Discussion. Temporal variations in groundwater levels. The piezometers 1810 G8, 1992 G8, 1962 G8, and 1142 are mostly located in a mountainous area that is the main recharge area for the aquifer system at altitudes between 1072 and 1170 meters above sea level. The groundwater level fluctuations observed in these wells appear to be affected by recharge processes from the mountainous region. The groundwater level fluctuations observed in the boreholes G blah 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 and the blah 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 G7 appear to be due to discharge processes, evaporation, and the pumping of groundwater for agricultural and domestic use. The groundwater level rise in the western part of the Sagres Basin may be explained by significant infiltration. May be explained by significant infiltration in recharge period due to increase of effective precipitation during the rainy season. The annual average precipitation in the western part is about 300 millimeters. Several studies across the world indicated that the rainy season recharge, groundwater extraction for irrigation, and lateral groundwater flow through regional circulation are major factors to control temporal pattern of groundwater levels in the study area. The fall in groundwater levels over the period between 1940 and 2011 was due to low recharge rates as a result of sharp reduction in rainfall over the last 2 decades, combined with high evapotranspiration rates within the study area due to semi-arid climate. Anthropogenic human activities also led to intensive groundwater extraction to meet the increasing demands of water resource for drinking and agricultural purposes due to population growth and agricultural development. Chemical water types. There was something. Chemical water types. Water type characterizes the brackish groundwater distribution in the central and northern parts and closest to the salt depression of the Hots region. Discharge zones. This is where it gets interesting. The abundance of this type in groundwater is probably due to the dissolution of halite or iron exchange reactions with clay minerals, as well as mixture with hot salt groundwater. The water type characterizes the moderately mineralized groundwater located mainly in the central and eastern parts of the basin. Water type facies was mainly found in the northeastern and northwestern parts of the basin. These facies represent the groundwater samples that are influenced by rock water interaction, mainly gypsum dissolution. So, gypsum. I have been talking about gypsum a million times. White rivers, turquoise colored water. Yesterday, I found some cement mine there, so I have been thinking about this alkaline no, it's not infrastructure. Environment. White rivers and such. Alkalinity. MgCI type is a mixture of waters from a dolomitic environment, hence the predominance of magnesium as well as the seepage is seeping from effective rainfall and or return of irrigation water. Maybe I don't find it now, but there was something very interesting. Yeah, anyway, they have different kinds of waters there. That's basically the main point. Somewhere they're talking about this brackish and drinkable, like clear water, or how is it? 300 millimeters, maybe it was up here. Yes. Hydrochemical characteristics. Groundwater chemistry in an aquifer is highly influenced by geological formation. That's actually the part I wanted to read to you. Hydrogeological conditions and anthropogenic activities. Human activities. Additionally, chemical composition of soil influences the hydrochemistry of groundwater during the circulation process. Chemical composition of soil influences. Groundwater characteristics of groundwater physiochemical parameters for the study area are summarized in tables 3 and 4. The pH ranges from 6.7 to 10, with an average value of 8.2, indicating that groundwater was neutral to slightly alkaline in nature. Like Tagliamento River in Italia. The electrical conductivity ranges, I don't know what they are, between 450 and 7030, whatever square centimeters, with an average value of 2000. According to the various studies, semi-arid areas, regions of Algeria, the electroconductivity values range largely from 644 to 23,800. So they are like highly conductivity anomalies or something there, which might be related strongly to the water. What I'm trying to tell you all the time. We have the waters in the heavens and the waters in the ground, and they will meet every now and then. It's not only so that the water comes down from the heavens, but the water comes up from the ground as well. Literally, as well. Haha. How funny. Anyway, the high EC, electrical conductivity, I guess, of groundwater is an indicator of high ionic concentrations. So, they are charged. We have charged waters. So, whatever emissions they might have, is it CO2? If there is like water coming on the surface and it emits CO2 and it deposits calcium and the rock starts to grow, like I have been showing you. But anyway, where we have been. High ionic concentrations may be due to anthropogenic activities, people activity, and geological weathering conditions resulting in high concentrations of dissolved minerals. TDS. What is TDS? I don't know. TDS is an important parameter. Yeah. Now that's the parameter, obviously, TDS. In drinking water and other water quality standards, anthropogenic sources, such as solid waste dumping, domestic sewage, and agricultural activities, may be one of the basic reasons for such high values of TDS. TDS in the groundwater of the area ranged from 303 to 4,134 milligrams per liter, which with an average value of 1,719. Freeze and cherry. Classify water into fresh. TDS below 1,000 milligrams per liter. So it's fresh water if it's lower than 1,000 milligrams per liter. It is brackish if there is more than 1,000 milligrams per liter. So 1,000 is one of those boundaries. And above 10,000 it's saline, and 100,000 or more, I guess, is brine. Categories on the basis of TDS concentrations. Based on this classification, 32% of the groundwater of the study area belongs to fresh water, and the remaining 68% to brackish water categories. So, groundwater mineralization increases towards the Hots region, which constitutes the discharge area of the piezometric water flow. Based on various studies in Algeria, the total dissolved solids of groundwater varies between 440 and yeah, and I promise to you, I will figure out what this TDS exactly means. I get the meaning of it. I don't have to really know what every letter means, but I still want to know. There was somewhere that the water level, that the groundwater level rises, is higher in the mountainous region than it is in these flats. Yeah, I don't find it now. Must be somewhere here. Groundwater levels, any aquifer tend to follow the topography, i.e. the groundwater level is higher in areas with high topography and lower in areas with low topography. This means the springs there are on top of mountains. Does it? Yeah, there's no hills in the flat. So if you go higher up, the springs will appear more higher up as well. Literally. I don't get these triangles. Summary statistic of groundwater levels. Manganese, natrium, kalium. Yeah. Interesting to look at these. I don't really get it. Yeah, in a way I get it. In a way not. This is just the composition of the water. Somehow it's really hard to not think that, this would be a mountain. But it's not. Something completely different. But I think I leave it here. I just wanted to show that there is something They have special water there. And I have been thinking about this quake might be related to groundwater, wide rivers, mountain waters, and such things. Yeah, charged waters. And here we talk about alkaline waters and stuff like that, which is very interesting. And we have these SO2 emissions going on. And then we had a quake, which was unconfirmed and now got deleted. Is there something going on? I don't know. There might be. There are many ingredients for something there could really be going on. But we have to follow that development of that thing. I leave it here. Thanks. Bye.